Hi, this is Addy, and today I'm joined by Mina, Rukutso, Danny, and Keith. And we'll be presenting the evaluation of fall detection systems for the aid of risk-prone individuals. Project requirements. Falling is an incident that occurs for every person throughout their lifetime while walking or standing. This type of incident, however, is more apparent for generations of people that are significantly older. Although falls do occur for people who aren't categorized as seniors, this technology may still be applicable for toddlers, preschoolers, and early primary school children. In most cases, however, devices and systems are more intended for the elderly as they experience more fall-based incidents compared to the generations after them. Age is the main risk factor closely linked with falls. This is due to the physical, sensory, and cognitive abilities that begin to decline as people age. When one combines the age factor with environments that are not apt for age population, the risk for severe fall-based incidents becomes increasingly great. A study done by Australian Institute of Health and Welfare found that falls are to be the main case for hospitalized injury and related deaths. Moreover, it is projected that by 2030, falls-based cases will increase by 100%. Hence, it is vital that a countermeasure is developed and supplied to all major health facilities in order to aid for this severe problem. The system must be able to distinguish between a fall and just a regular activity or exercise performed on the ground. In addition, this must be able to respond without any delay or hesitation when the incident arises, alerting those needed in assisting the person in crisis. Performance criteria. Performance criteria are an important step in making decisions about comparable projects. These criteria will be used to quantify the strengths and weaknesses of individual solutions, allowing for unbiased comparisons. Senior citizens make up a large portion of the mentioned risk-prone individuals and generally possess a lower yearly income. It is found that on average, senior citizens generate yearly income of 29,000. Hence, when implementing biomedical technologies such as fall detection systems for public consumers, affordability is a key consideration. Accuracy in terms of fall detection system refers to correctly recognizing the event of a fall, hence being a major consideration for the well-being of risk-prone individuals and deserving a substantial consideration. Reliability in terms of fall detection system refers to the effective distance range for the technology to operate at an optimum level. Statistically, it is known that 56% of fall incidents are likely to happen outside the house. Hence, it is important to consider the distance range restricted for the fall detection system to work reliably. Accessibility should also be taken into consideration. A possible user should easily be able to operate the system with clear and systematic approach. It is known that the system may be targeted towards senior citizens who are generally considered to have difficult time using smart technologies. A poorly designed interface of a system will lead to improper usage of the system. This can lead to risks to the users themselves, damaged or even poor performance of the system. Hence, for these reasons, ease of accessibility is highly considered.
Now, onto the design evaluations. We're going to be looking at a non-wearable fall detection device. The first example is designed by Alloy Care. It has 24 hours, 7 days voice-activated care button for customers to get access to professional emergency response. There are two ways of requesting help. You can either press the care button or say the word emergency repeatedly until you hear the response sound from the device. So either way helps the customer to connect with the emergency response team. To have a device like this, there's a monthly cost of up to $50 for the most updated version of the service, plus a one-time installation fee of $350. If the product is not functioning as expected, the company provides free technology services. Therefore, by approximation, the total cost for 1 year would be $950, neglecting costs for maintenance. So it is scored at 8 according to the success criterion for affordability. According to its website promoting information, the coverage of this device is up to 175 degrees and 50 meters. From Australia Butte Search website, the average dimension of a room in a house does not exceed 7 meters. Therefore, the design system is sufficient to provide an accurate detection. Therefore, it gets a score of 8 for accuracy. The score of reliability is 0, mainly because of the limitation in ranges for mobile companion, which means outside of house, customers are very hard to get access to services without carrying a button. So, um, the installation of software for this device can mostly be done by technicians. However, the the connection between the the connection between the user and caregiver needs to be done manually through online apps. This is why accessibility is scored at 5 for this design.
Next up, we have design number 2, SureSafe Go Anywhere Alarm. Now, affordability of design. The design of the SureSafe Go alarm consists of a wristband, a belt clip, and a lanyard costing a one-time payment of $479 with a $40 yearly recharge on the SIM card. That's an estimated cost of $88 per year for the first 10-year period. Now, the SureSafe Go alarm provides protection anywhere utilizing smartphone communication technology, and it uses a SIM card to make emergency calls without requiring a landline connection. Based on that, we can give a rating of 10 based on the performance criteria. Now, over to accuracy of design. SureSafe Go includes a two-way communication feature that allows the user to talk into the pendant. Now, when the button is pressed on the pendant, the user's location is sent to 5 emergency contacts and connects the user to the main response center. Now, based on those, we can give a performance rating of 8. Reliability of design. The SureSafe Go design is considered to be rangeless without additional requirements. The alarm uses SIM technology to contact and communicate emergency contacts for assistance. Now, the design includes an inbuilt GPS location feature and is LX6 certified waterproof, with flexible wearing options of on the belt, around the neck, or on the wrist. We give that a rating of 8 based on performance criteria. On to accessibility of design. The SureSafe Go design does not require any initial setup procedures, and as such, it includes a pre-installed SIM on purchase. Now, with the accessible and simple button press for assistance, and the GPS tracking feature accessible through pressing that button or automatically on fall detection, we can give that a rating of 10 based on performance criteria.
Based on the success criteria and the relative scores acquired from both wearable and non-wearable fall detection services, wearable systems were ultimately chosen as the final design, and the following relevant concepts regarding its internal and external interfaces will be discussed. The infrastructure requirements of the majority of wearable fall detection sensors are the inclusions of subsystem modules, hardware connections, GPS tracking, and wireless networks. If the proposed design solution were to be implemented nationwide or globally, it is important for the organizations to reevaluate the wireless network designs due to the increase of network traffic to the main system and base stations. Additionally, the assessment of existing networks are required to ensure the security and privacy of connections to the service, such that patient devices do not affect the main healthcare network that medical professionals use to help better coordinate care. For the monitoring requirements of our product, it will ultimately consist of reliable communication between the consumer, the stakeholders, and the project team, as well as their constructive feedback and criticism. In order to allow our team to measure the success of our product, we are taking into consideration any health conditions that our consumer may have and to take the relevant actions and precautions. This may include regular checkups of the product to evaluate the durability, longevity, and the accuracy of its recorded data. In regards to the communication requirements, however, there are a variety of communication processes that need to be addressed due to the high dependency of research developments and capacities. Between the high-level systems and their respective subsystems, the communication networks such as remote and wireless connections are crucial in monitoring a patient's health as well as notifying emergency contacts for any critical changes. Wearable medical alert devices can further propagate information and business systems already in place for fall detection technology. The medical alert tool will help attain information in terms of accuracy of the device, as well as contribute in regards to the statistical data in the medical field. The collection of data is possible through the increased use of the device and the continuous detection of falls. This is true for studies such as the one conducted by Dukas and Magalogiannis in 2013, where various data mining techniques were used to acquire statistical information on fall detection systems in order to improve their accuracy. Business systems can also benefit as the success of this product will result in an increase in demand among clients who are prone to falls, especially individuals over the age of 60, as they suffer from a greater number of falls compared to other ages, according to the World Health Organization in 2021. To add, increasing the amount of data required by fall detection technology can also give rise to new innovative designs into detection systems in general. The business model which this medical alert system will cater towards is its convenience and increase in accuracy. Due to the fact that it can be implemented into wearable devices, it can already be easily integrated into everyday life without much hindrance. With the rise of smartwatches, collaborations with fall detection systems do not sound too far-fetched and will most likely be a necessity in the future. Proposals already on the rise, such as suggested integration of these monitoring systems into smartwatches for use in critical medical environments by Stradolini and colleagues. Its accuracy regarding detecting falls will also be a major factor in this business. This is because better accuracy will mean better negotiation of false alarms and ability to predict falls, which is very attractive for buyers.
It is important that legal and ethical matters are strongly considered. In order to uphold ethical standards, organizations must sufficiently explain their intentions and provide their clients with a privacy agreement that authorizes and provides proof of consent for any individual's data to be taken. Furthermore, this aligns with any legal considerations, as the agreement of any data collection has been requested before the device begins to implement any of its functions. The environmental concerns can be categorized into three sections: energy consumption, greenhouse gas emission, and the use of materials. In the process of manufacture and use, energy consumption cannot be prevented but can be reduced using various approaches. One of the examples is that Samsung tried to minimize power consumption and standby power monitors in order to decrease the use of electricity in the use phase of the device. Therefore, the amount of greenhouse gas emission could be diminished by this action. The life cycle of a product includes the pre-manufacture, manufacture, distribution, use, and disposal. Every stage in the product life cycle is equally important. The use of heavy substances and chemical resources that may bring threat needs to be prevented, considering disposal of products and the ends of their life. Through analyzing the potential issues, the manufacturer of wearable fall detection systems will be considering all these aspects in order to provide a more sustainable environment. Personal emergency response systems, PERS, have been the most common type of fall detection. PERS are pendants worn around the neck which enable the wearer to notify designated emergency contacts of a fall occurring. Though they are practical, there is still much room for improvement in terms of their accuracy. To add, there are social stigma surrounding the pendants, as they can make a person seem inferior by social standards. As a result, it is therefore not the most viable solution in terms of software and design, hence why there is a growing field of research for the development of fall detection systems. The rise of smartwatches is a great contribution to the development of fall detection systems. Not only are they practical, but their design is much more sleek compared to that of a pendant. Smartwatches such as Apple Watch have pre-installed medical monitoring systems for their users. Although the Apple Watch may be expensive, there are many other alternatives in the market that are much cheaper and also function as a medical alert system. As the industry continues to grow, there is a likely chance that smartwatches will become more cost-effective and technologically advanced for fall detecting in the future. There is also work regarding environmental mapping of fall detection systems. One such case would be the VR home, which can be placed on walls and scanned to the residence area in order to detect their falls. This way, environmental-based fall detection technology can not only help the individual when it comes to sudden incidences, but it also takes away the inconvenience of carrying such technology around. Falls can take place at any location, hence implementing features that will make sure the device functions during weather conditions of intense rain, snow, and heat will make consumers more confident in such devices. Another recommendation would be to integrate the system with mobility aids to fully optimize the services it provides. Overall, the report was successful in analyzing the systems contained within the project. It was able to thoroughly investigate the requirements of the design in terms of infrastructure, communication, information, and business systems. A business model was established detailing the process of implementing the technology in the market. Finally, a risk assessment of the project was undertaken. Considerations were also made within safety, ethical, legal, environmental, and sociological issues.